Yeah, hello everybody. So I'm Ernesto. I am co-founder of Board Course Developing, BGD Labs. Before I was on the Aave Genesis team, I was CTO on this protocol that probably quite a lot of you are familiar with, Aave. And yeah, today I will be talking about the next iteration that will be applied on the Aave protocol for governance. So currently we have Aave Governance v2. So this is about Aave Governance v3. Yeah. First of all, I don't know how familiar is everybody with Aave Governance because it's a bit more hidden piece of the puzzle compared with the liquidity protocol that I think everybody knows about. But in general, it's quite similar to a lot of other governance systems on chain. So basically, it's a set of smart contracts with which the Aave token holders and control every other piece of the Aave ecosystem. So yeah, these smart contracts control all the instance of the liquidity protocol. So the current one is Aave v3, but also Aave v2 and even Aave v1. The safety module, which is where people deposit Aave and it is submitted to slashing if anything happens with the liquidity protocol. And even the Aave token itself, and some other minor pieces of the ecosystem. How it works is, well, you have Aave tokens, somebody creates proposals that basically are executable payloads to do certain action on the protocol, and then holders of Aave on Ethereum, or people that receives delegations from those holders can just go to the smart contract and vote in favor or against the proposals. Well, Aave is, as you probably know, is not only on Ethereum, it's also on Polygon, on Avalanche, on Optimism, Arbitrum, a lot of places. So the current Aave Governance v2 also contemplates that. So apart from the voting that happens on Ethereum, whenever a proposal needs to be executed on another network, well, the system just supports what we call cross-chain. So the decisions that are taken on Ethereum gets breached to whatever network requires the execution. Now, this type of governance exists for, let's say, quite some time. If we can consider quite some time, I think around two years, more or less. And one of the main problems that it has, and to which everything boils down, is that they are expensive to run. If you need to vote with your tokens, you need to do a transaction on Ethereum. As we all know, Ethereum has a lot of good things, but still is not the cheapest network to interact. And this, in the case of a system like governance, on which you require as much participation as possible, well, it's a barrier. So when you have Aave holders that have maybe 1 Aave or 10 Aave, spending $5 to emit a vote, and especially right now that there is quite a lot of proposals all the time, so spending $5 every time that you need to vote, every week once or twice, is not something that will work in scale. So maybe the main question is there room to actually improve what is de facto standard of on-chain governance systems, and obviously always keeping this on-chain and with no points of centralization? Well, the idea is that, yeah, it's possible that is talked about, and we think that we have solved with Aave Governance v3, and this is, well, a bit of a diagram of the system that I will display afterwards. So, as I mentioned before, Aave Aave is basically in all the big networks out there, the liquidity protocol I'm talking about. The execution of proposals on Aave Governance v2 is also able to go to all these networks because somehow you need to control them. Can we do kind of the same with the governance system and optimize it? So yeah, the idea is that we can. The problem again is that right now we have almost 200 proposals, all on-chain proposals that Aave holders need to vote on. So, and it's getting accelerated. Like at the beginning of the year, there were maybe 120, and in 3 months we have like almost 60 more. So like this high load is creating a bit of a problem that needs to be optimized. The way of optimizing this is relatively simple to understand. If we have like Ethereum that is a bit of expensive environment, but then we have multiple other environments on which Aave already has trust, like Polygon, Avalanche, or optimistic rollups, even CK rollups that are coming close. Well, we should use those networks somehow, like, and the advantage that they bring to the table. This is also pretty important because, and it was not possible like even maybe 1 year ago, and for sure not 2 years ago, because the bridging ecosystem, like the bridging technology, is getting mature more and more. So like what before was really, really experimental when, for example, on Aave we introduced like this cross-chain system, now is becoming a reality. So yeah, it's the right moment to experiment on the application side. So, which are the parts of this new system? Well, Ethereum, we are not just removing Ethereum from the picture. Ethereum is will still be the core of the Aave governance, but it will be a bit different. So, for what we want liquidity, for what we want Ethereum is because of its security, and because everybody is already understanding that Ethereum will become like a settlement layer and a security layer in the future. So in our case, we know that the participants on the governance needs to be the Aave token holders. We know also that the balance of Aave like majorly is on Ethereum and will stay that way because it's the most secure place still. So we know that the core of the governance still needs to be Ethereum. But the big change is that it's not anymore, let's say, a monolithic system where everything is on Ethereum, but Ethereum becomes like the governance part on Ethereum becomes like some kind of access control component and validation component. So like it will be a smart contract on Ethereum, the one that will check that everything is valid when somebody votes, and it will be the one that checks that the quorum requirements to understand if a proposal is approved or not, they are passed or not, basically. So, yeah. But now, like before, voting was on Ethereum, and this is the big change on Aave Governance v3, because we know that voting is the big bottleneck. So people ideally should not spend almost anything while voting. And this is what we are actually moving to other networks. So the idea, as well, maybe is more or less clear in the picture, is that all the networks will be candidates for voting. Per proposal, only one network, but all of them will be candidates. And this will be done by deploying these kind of voting machines on each one of the networks, and then by selecting every time that somebody creates a proposal, which network are going to use for this proposal. Yeah. And then Ethereum will still be another network on where voting can happen, but the idea is that it will be like the last resort, like a voting machine or voting network. So if everything goes well and it's way cheaper to vote on Polygon, or in Avalanche, let's say, well, proposal 200 will be voted on Polygon, 201 maybe on Avalanche, because it becomes a bit cheaper at that point. But if there will be any problem with Avalanche or Polygon, the system can, like proposal 202, could be voting on Ethereum. And basically it will mean that it will still be expensive to vote, but it's perfectly decentralized and the system doesn't get blocked or anything like that. Now, all of this, as you can imagine, like involving so much networks, like needs a bit of an improvement on our cross-chain infrastructure, which helps like to right now just move the decisions to other networks, but in this case it will be more back and forth movement because you need to create a proposal, move it to vote to some other network, return it to Ethereum to validate, move it somewhere for execution. So for that, we are also improving the Aave cross-chain system that we have because right now, like the reality is that it's quite dependent from the canonical bridges. Like, so whenever we want to execute something on the Aave v3 Polygon, our system under the hood uses the Polygon canonical bridge to send a message to that network. Or whenever we want to do that, the same on rollups, the same. With this new system, we are, and knowing that there is more bridge providers apart from the canonical out there, we are just building the base layer to be able to, for Aave to define a consensus of which bridges are acceptable, which not, if we accept like 2 out of 3 as a valid confirmation, or in some cases maybe it's just with one bridge is the most secure one, so we just use that bridge. So what this, like the big advantage of introducing this kind of layer is that the expansion of the protocol that we expect that will continue during this year with these new networks that are appearing, well, this will be more flexible for us on the governance side, on the control side of those networks, to expand there and not having any kind of centralization via any kind of multi-sig or anything like. It will be just, if an instance of Aave gets deployed there, pretty easily we will be able, like, if any breach exists, to plug our cross-chain infrastructure and support that network almost from day 0. Yeah. So now I explained a lot of like theory, but how it actually works, how is the flow of a proposal on this new governance. It's actually not so complicated, I hope. So, yeah, everything starts like, for who is not so familiar, to create a proposal on Aave, you need to have Aave tokens. At the moment is 80,000 Aave tokens, which is quite a lot, but yeah, everything starts with some entity that has the Aave tokens. It's a bit more complicated than that, but let's assume not. So like the first step is that the proposer right now will create like what the so-called payload, which is just executable code, a smart contract, on the network, one or multiple payloads, by the way, on the network or networks where the action needs to be executed at the end, if the proposal passes. So in this example, like, let's say that we want to change some configuration on Aave v3 Polygon on the liquidity protocol, or list an asset. So the proposer will deploy a smart contract, which is the payload on Polygon. When this payload gets deployed, the proposer will receive from the smart contract an identifier, just a number, and of course, like, he will have the reference that is a payload on Polygon. So with that, he will go, well, he receives the identifier first, of course, and then he will go to Ethereum, which is, as we commented, like the validation layer, and there, the governance core system will identify, okay, this wallet has the 80,000 required Aave tokens or delegation of Aave tokens. If that is the case, and with that identifier of the proposal in Polygon, he will be able to create, let's say, the proposal on Ethereum. Here is when the magic starts to happen. So immediately after the proposal gets created on Ethereum, if it will be on B2, there will be like some time delay, and then voting will start on Ethereum. Right now it's different. Once the proposal creates, like, there will be a breaching, like, to Polygon, in this case, because it's also the voting chain. And what will get breached is the block hash of just before when the proposal was created. I will explain a bit more why. But yeah, this breaching will go through our cross-chain infrastructure and will kind of notify our Polygon governance part, voting part, that there is a proposal to be voted on. So it gets received by our so-called voting machine on Polygon. And, well, there is some technicalities, but voting starts on Polygon. Now, if you have Aave token, you just go to Polygon and just vote, like with your Aave token. But the main question here is like, okay, but I have Aave tokens on Ethereum. How can I vote on Polygon directly and without breaching? This is important. There is no breaching involved. Like, so you have your wallet with Aave tokens on Ethereum, you do a transaction on Polygon, not on Ethereum, and breach to Polygon. And the answer is something that is called storage proofs. And that is the main reason of why before I mentioned that when the proposal gets created on Ethereum, the block hash gets forwarded to Polygon. So how this works is the block of Ethereum contains all the information about the balances of the users. It's just that it's like in a compressed way. So like, because the block has like the so-called state tree, which contains all the information, all the data that is stored on Ethereum. And basically it acts like a snapshot of balancer or whatever other data is on a smart contract on Ethereum. So what we do is that we send the block hash to Polygon, and at that point we have a snapshot of Ethereum on Polygon. So when the user votes on Polygon, the smart contract is not reading the balance. The user is passing its balance and is proving with the storage proof that he had that balance on Ethereum whenever the snapshot was taken. So that is the way of, you don't need any breaching, you just go with your balance, and the smart contract on Polygon understand and can validate that you actually had that balance on Ethereum. And that is kind of the magic. So people just vote on Polygon, and after the voting period ends, this is kind of the same as before on Aave Governance V2, the decision gets breached. So the decision will be, for example, that proposal had 200,000 yes votes and 50,000 no votes. That will get breached, normal breach, not storage proofs, to Ethereum via our same cross-chain infrastructure. It gets forwarded to the smart contracts on Ethereum from the breach. And then, like, there is like some queuing, time lock, same as right now. But if, for example, there is like a payload also on Ethereum and on Polygon, something will get executed on Ethereum. And to execute something on Polygon, again, we will send like some message via our cross-chain infra that will be received on Polygon, and the change will be done. And yeah, that's it about the flow. But, well, I didn't explain so much about the cross-chain infrastructure, just about this consensus and so on. What is about like this? Is there anything new or not on the cross-chain infra? So, yeah, cross-chain infrastructure works kind of this way. So we have in the left Aave Governance V3, like a representation, which deals with proposals, right? So what happens is that in different times like, of the life cycle of the proposal, let's say that this is like an execution of a payload that was already approved on Ethereum. So the system will send the proposal, the governance system will send the proposal to our cross-chain. There is a component on Ethereum which understands which are the, let's say, whitelisted breaches, underlying breaches that could be like Chainlink CCIP, it could be layer 0, it could be the canonical breach of the network, it can be whatever. And then when all of these breaches, or at least like a number of them, sends the message and this gets received on the recipient chain. We have another smart contract there that understands which is the consensus rules. So imagine that we have layer 0, CIP, and the canonical bridge. So we could configure that if 2 out of 3 tell us that, that this message was approved on Ethereum, well, the system will just accept it as correct and will forward to what we call the executor, which is a simple time lock on this side that after the delay will just send to the, well, in this case, one of the instances of the Aave protocol, which is the Polygon one. So, which are the main advantages of the system, like from high-level perspective? So, first of all, what I mentioned, it will become really, really cheap to vote, as you can imagine, because it will be a relatively simple transaction on Polygon, and what right now could cost $5 to emit a vote, potentially it could cost like 1 cent or 2 cents to emit a vote on Polygon. And this is pretty huge because ideas like, for example, the Aave DAO paying on behalf of the users are pretty realistic. At the end of the day, like we have 200,000 Aave holders more or less, but realistically, if 5,000 participate on voting, so it will be 5,000 1 cent, so it will cost the Aave DAO $50 to cover the whole cost of governance, and it will be factually free for the voters to participate via some kind of system with relayers and meta transactions. Another big point is that we have these dynamics of delegation, of voting delegation and proposition delegation, and the big change is that there is no change. It will just work as usual. It's just that on the Polygon perspective, it will be possible for our smart contracts to understand that this is a balance of delegation instead of balance of voting, but for the user it's just exactly the same, for the delegators it's exactly the same. And then another big advantage is that right now, like with this system of modules, like it is fairly easy, like to implement like the voting logic even on non-EVM chains, because at the end of the day, like the Ethereum part is quite agnostic of how the voting works. So the Ethereum side only sends somewhere a proposal that needs to be voted, whitelisted from where it receives the response, and then if it's whitelisted, it just accepts yes votes and no votes and validates if that is good or bad. There is like some other advantages, but it's a bit more technical. So for example, those of you that are like developers, like you know that for governance tokens, usually you need to have snapshots of balance. So every time that somebody transfers and a snapshot gets made, because the governance systems read from those snapshots, historic snapshots. So with this system, we don't need any more of that. Like we just can remove all the snapshotting, and it will be just a completely simple ERC20 token, let's say. Yeah. Then the smart contracts that are on Ethereum and that hold Aave will be able to vote exactly the same. Not exactly the same as all other voters, because in that case, like the contracts cannot interact directly with Polygon, obviously, they are on Ethereum, but it will be possible through our bridging system, like the smart contract on Ethereum that has Aave will send a message that in this case will be, I want to vote yes, and it will need to set it to the voting chain, which can be Polygon, for example. Then, it's a big change that we will be able to add new assets that with voting power. Right now, it's not so simple because, for example, the snapshots. So, like, if a token, if you want to add, like, I don't know, some random token, which makes not so much sense, like, but to give it voting power on Aave ecosystem, it requires that the token is implemented in a certain way, which means that, like, tokens that are not upgradable and don't have those features are just not eligible for that. And you will need to wrap them and so on, which is too complicated. This way is fairly simple to just implement a strategy that says, okay, we want to give like 10% of the voting power to this other flavor of Aave, let's say, and it will just work. And then, yeah, something more on the technical side is that it becomes way more isolated and way more modular, the connection between the governance system and like liquidity protocol and everything else. So, yeah, for now everything seems like advantages, like fully decentralized, like cheaper, like and no disadvantages. Which are the disadvantages? Well, actually there is not really many disadvantages or almost no disadvantage. It's just that with some new systems, like, and because of how everything goes around these storage proofs, that is a bit interesting field. So one of the problems is that like CK or validity rollups, they are not so happy with storage proofs because of how the hashing, for example, works, the default hashing of the network. So even if all the transactions on, let's say, CK-AVM of Polygon will be cheaper for a reason, whenever you try to do storage proofs, it's actually quite limiting because the gas implications, the computation implications of doing that in that environment are high. You have also a bit of more unpredictability of the voting duration, but pretty minor, and this is basically because whenever, as you need to do bridging, like back and forth, you will have a small delay of that bridging. Obviously, it's not optimism or Arbitrum, optimistic rollups that have like big delay, let's say, for fraud proofs to come back. You cannot use it unless you want to have like a voting period that is really, really long. But both of them, for example, support like fast bridging with third-party bridges, and with our cross-chain execution, it could be perfectly possible just not using the canonical bridge of optimism or Arbitrum. And then, like on the not so technical side, it's going to be interesting also how the community is going to choose on which chain to vote every time. Because, as I commented before, it could be a situation on where like the next proposal that gets created in Aave and the proposer chooses can be voted on Polygon. And potentially could be a proposal even that doesn't touch Polygon afterwards. It touches only Avalanche. And next proposal, it could be voted on Avalanche. Next proposal could be voted on Optimism. So it is going to be interesting, like how the community is going to decide to where to vote, if it just where is cheaper or not. And yeah, that's it. If there is any question. If we observe like that there is like some change on the dynamics, more turnout of voting participation. So first of all, the system is not live yet, so we don't know. But how we thought about this is that there is not really any potential negative consequence in terms of participation. So like even, of course, it's not realistic to think that just because we introduce like and make cheaper voting that like all the Aave holders will vote, because it's not a matter of being cheap or not. It's just a matter of, is people capable of taking decisions? Like, do they want to do it? It's not even if it's free or not. So we don't know, but pretty realistically, we know that there is a lot of users that they say, like, we don't vote because it doesn't make sense if I hold $100 in Aave to spend $5 every time that a proposal happens. So realistically, if we have participation of, let's say, 1,000 or 2,000 people right now, we should expect at least multiply that by some numbers. Like maybe not by 100, but having like a bunch of thousands more participating is pretty clear. Yeah.